Hello, everyone. It's been about 3 years since I spoke to this crowd. I've been hiding. It's nice to be back. Okay, so I'm going to talk to you about various random bits of information. There's no theme except that I have a whole lot of little info bits that students find useful, and only one of them makes you scratch your head. So the rest of tonight, except for that one slide I'm going to show you, is light and easy, but helpful. So that's nice. Things that aren't hard, that make a positive difference in your life. And I'm going to cover a broad amount of ground. I'm going to try to aim for about an hour and a half. And if you have questions that are pertaining to the subject matter somewhat, I'd be happy to answer them if we don't get sidetracked too much. Have I covered myself enough there? Let's see, do I have a clicker? Does it work? Oh, look at that. So, the website getscala.com talks about the products and training that scalacourses.com delivers, and you can go to that site and check it out. I'm not going to give you a big sales pitch, but this is what feeds me in particular. And so if you'd like to support this happy smiling face, please go there and see what is there. We have some laptop stickers which look like this one. They're in the back there. Help yourself. Put it on your laptop. Take a photo. Tweet your photo to scalacourses.com. And if you do that, we'll put it up on our site. This is the view from James Ward home office. He's in Colorado. Yeah, we'll do that for you as well. Oh, good. So just a little bit about me. I'm the managing director of scalacourses.com, i.e. founder, chief cook, bottle washer, the guy who takes out the garbage. And we make videos that our instructors write, and it's all about teaching people how Scala and Scala-related technology works. I also wrote the web app that is the authoring tool that we use and the delivery mechanism. So it's written in Play, Akka, Scala, of course, Postgres. What am I forgetting? So we're eating our own dog food here, big time. And a lot of our code examples actually come from this. I founded SF Scala, and then I moved on to this group and grew it to the world's largest Scala user group during my time here. Vlad has taken over for the last 3 years or so. And before that, I founded the Silicon Valley Ruby Conference when Ruby was a new thing. And before that, AutoCAD User Society, that was again the largest AutoCAD User Society. That's a few years ago. I'm an old guy. I also work as an expert witness when I'm not doing those things. I opine in the fields of distributed systems, e-commerce, and intellectual property. Some of the cases last 2 years, so when I say only 15 cases, that's actually sometimes a lot of things. So I will sometimes come at a problem from a different point of view from the typical engineer. I'll say, have you considered who owns what you just did? So we're not going to go there tonight. It'll be a temptation, but I'm going to control myself. So about scalacourses.com, we do online training. We've been doing this now, this is our 4th year. And we have self-study and instructor-led training. So the self-study is you sign up, you get your access, you watch the videos, you do the exercises, and every once in a while you hit a problem that you can't figure out. So then you ask for help, and one of our live human beings, which might be me, helps you out. So that's kind of an ad hoc on demand. And the other one is the instructor-led model, where you say, we want our people to have a certain proficiency level by that date, and we're going to go through this material according to this schedule, and we're going to have TA time according to that schedule, and we basically meter it out such that the team reaches the objective at that point. So I work in both modes. It's all video conferencing We don't go on site physically. One of the other things is I've spent a little time in academia. It didn't suit me. I'm an engineer, actually. I'm an electronics engineer. And so I care about just getting things to work, because that's really all engineers care about. Don't give me all the details. Does it work or not? Let's make this thing work, right? And that's kind of the philosophy. Minimum of theory, maximum of what really matters here is to know that X is connected to Y, and you pull on Z, and then you get your result out. And here's some understanding of how that process works, and here are the parameters that influence that. That's generally our approach. All the courses have a set of videos and notes equivalent to an O'Reilly-sized book. So, for example, Introduction to Scala, it's equivalent to about 500 pages, the standard O'Reilly thump, table thumper. And you have access for a year to that information, and we keep it up to date. So the Introduction to Scala course started in 2012, and we've now brought it up to current, Scala 2.11.8 was released last week, and we had known this for some time, and we've been playing with pre-released versions, as we have with Scala 2.12 and Play 2.5 and so on, and that's all in our courses already. So it's current. So you're current for a year. So that's the ad. And into the info. So got past the ad. Excuse me. Here's some URLs which are kind of nice things to know. I'm going to provide slides for everything you see on the slideshow. It's going to be in a PDF. I'm going to make it available. So you don't have to randomly, take photographs or scratch it all down. I'm also going to show you some live code from real projects that I can't give you. So what you see is all you see. But if you see something that looks like a slide, you're going to be able to get it. So this slide in particular is, I think, something you'll want to have. You probably know the first URL. That's the current Scala doc for the shipping Scala version. So if you just know that, you'll always see what's current. And then this number 2 there, it's the same thing. It's the prose for the ACA documentation. It's the written word. The number 3 is the Scala doc for ACA, and it's current. Number 4, now we get into the dodgy bits. That's the current URL for SBT documentation. It's prose, it's not an API. And that has changed in the past. It's not consistent. They don't publish like a current URL that will always take you to the current documentation. And if you do a Google search for SBT whatever, you'll probably end up at an old page, because Google seems to think that something that's been around for a while is more authoritative. Unfortunately, it's less useful. And there's no indication on the page unless you, no big thing like the ACA people show is, hey, this is old. You might want to see the new documentation. Click here. It's none of that. It's like, wow, things really haven't changed much, have they? Well, they have, but you're not looking at the right documentation. So this is the current URL. I've put in a request to, that something be done about that. And then there's no search on the SBT site, which is a problem because, as I said, if you do a Google search, you're going to end up on the old documentation. So this URL will take you to the current SBT. It's a form, so I'm going to show it to you. I have this queued up somewhere, just so you can see what I mean. Here it is. This is the form that, if you click on that URL, you come to this page. And this is the actual SBT documentation, and you can just type in for a word or a phrase, and now you're searching for what you need in the current documentation. So I've also requested that a link to this be put in a form at the top of the page so you could type in something and get to the good stuff. But right now that isn't the case. So you might want to look at that when I give you the PDF. Then it comes the play. Play people have their own idea of how documentation should work. It's not compatible with what I've just talked about. This is a redirect. So this is not a stable reference. You type that into the URL field of your web browser. It will take you to the current page of the current documentation, but it'll rewrite the URL. And so if you want to see the same page, the current page next week, you've got to enter that again. It's not like we saw before, and like number 1 there. That's a stable URL. You can just paste it in. It comes back, and you're seeing it. It's like linked in the background. So you can't, for example, tweet this URL because it'll resolve before it's tweeted. And you won't see this. You'll see what it resolved to, which is kind of frustrating. Similarly, for the pros, this is a URL rewrite. OK, so let's look at Introduction to Scala. Now, I'm not going to go through the whole course, but I should show you. This is the front page of scalacourses.com. And I'm not logged in. Nobody's logged in here. So you would all see that. There's a 5-minute video that tells you what Scala Courses is, how it works, how to get the best value out of it. And as always, there's a transcript for the video. Every video has a transcript. So if you have trouble hearing the word or you want to click on the link, it's all here. So it's a word-for-word transcript. We have courses grouped by theme. So there's Core Scala, there's some play courses, and so on. So let's just take a quick peek at Introduction to Scala course. There's a 2-minute video that kind of says what is in the course. And of course, the transcript is there as well. So you don't actually have to watch the video. If you prefer to read, you can. You won't see what I did, but maybe for this video it doesn't matter. Other videos, it will matter a lot. So it's up to you. Then there's a revision history for the entire course at this level. It's aggregated. And so this course has been around for 4 years. It's the 4th year of this course. And so, it goes on for a while. But that's what's happened. And then there's an outline. This is automatically generated. So it goes through each course and it parses everything. And you can see the revision history for each lecture. I guess I am logged in. Oh yeah, I am logged in because that's a live link. I can actually jump over to that. And I'm going to jump over, but I'm going to take you to IDEA, the IDEA lecture. Here it is. So, I can maximize the video or not. And I'm not going to play the video for you, but, it's a video. And, of course, it's got cross-references. So which other lectures reference this lecture? This is automatically generated, so it's always up to date. And what other lectures reference this one? Here's the outline again. Again, the famous revision history and the transcript. So you can see step by step, blow by blow. If you want to work through it and you're saying, it's not working, right? Every keystroke is here. So it's not like you have to find where in this thing do I find it. You can just do a search for text on this page and it will find it. And speaking of searches, we do offer play, let's say. I don't have to hit enter. Excuse me. But it searches all the courses and it's grouped. So you can say, show me whatever, and then jump around between material. OK. The Scala REPL. You all have used the Scala REPL, right? So it read, evaluate, print, loop. And something a lot of people don't know is that Control L clears the screen. Yay! Big deal. Well, it could be nice, I suppose. This is more useful. To get a colorized REPL, I find it easier to read because it kind of, here, let me show you why I like it. So if I say Scala, 1 plus 1. So what it's done here is I've got the prompt is magenta. What I typed in yellow, the name of the variable in blue, the type in green, the value in yellow. In order to get this, which I think is kind of nice, it's very easy. Who already knows how to do this? Oh, I'm actually showing you something useful. Okay, good. I'm happy about that. Really, you just define this Java system variable, scala.color, give it the value true. And if that's in force at the time you launch the Scala REPL, then you'll get colorized output. And an easy way to do that is to put this in your profile, depending on the version of the Unix work-alike you might have. It might be .profile or some other file. And we just alias that, so whenever you type Scala, as I have, then you get the colorized REPL. Easy. Okay, now this is useful. Pasting a transcript. Let's say you've gone to a web page and there is a transcript of a REPL session, with the prompt and what the guy typed and what came back and another thing, and it goes on for some. And you might think, well, I want to reproduce that here, and you go and pick out all the things that the human typed and trying to paste them in one by one. You don't have to do that. Watch. The fingers will never leave my hands. I'm going to copy this transcript here. So I'm going to grab the Scala prompt, what the person typed, and the response coming back. And if it was, if they had typed a multi-line expression, you would have had those margin characters, the vertical bars on the left margin. And you would grab all of that. So I'll just put that in the paste buffer. I just paste it right in here. Oops. Can we go up, please? There. Now, it says right at the beginning, it detected a REPL transcript. That's the first thing that got pasted in. It started with Scala greater than, right? Because that's what I had copied. And then as soon as it saw that, it said, you're pasting in something. Let me know when you're done and hit Control D. But if I hit Control D now, nothing will happen, because I need to be at the start of a line. So I hit Enter, and now I'll push Control D, and it will work. So something else I'd like you to notice, in the original, res13 was an automatically allocated variable, because we had asked for a computation to be done or referring to some value, and it just allocated a new variable. But in the replay, that number wasn't stable. It's res1. Whereas the named variables, x and y, those are stable. So you get the right answer, but these automatically generated variable names will probably change. And that's fine. It's not a bug. So this is a great thing, especially if you're trying to follow along with a class and you've got all this code and you just want to blam it in. You don't have to pick through the code anymore. Just grab the whole thing and poof, Control D. So there. So Scala 2.11.8, which was released just a few days ago, has some improvements in this area. It's something called a REPL here document. So if you're a Bash programmer or a PHP programmer, you've seen here documents, which is basically you start off a sequence of statements with an indication of what a unique string will be that terminates. And so you say, okay, here's some stuff. Look for this termination string. Blah, 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 termination string. Go. And so that's good for scripting. And I'll show you what that looks like now. 3 variations. So the first one is this. We're going to paste in. So the colon paste command is used with the REPL or with the SBT console. Let's say you want to define a class and its companion object together. You can't normally do that if you're just typing in first the class and then the companion object in the REPL, because in order for that to work, the Scala compiler has to see the two things together. It has to know that these are in the same file, as it were. But because of the way that REPL is constructed, each line is like a different file, kind of. And so there's no way for you to define a companion object with its associated class unless you use colon paste. So what you say is colon paste. You're in paste mode. You can type in the definition of the class, the definition of the companion object, Control D. They both get compiled together at the same instant, and the compiler knows that these are connected. Well, that's what's going on, but now we have colon paste and something new, less than EOF. Now, EOF is an arbitrary string. It's a string you'll find a lot, but it's by no means necessary. It could be Fred, it could be I'm really finished now, or whatever. But we'll just say EOF. So colon paste, less than, and then some string, and then we have two lines, the object and the companion object definition, and then EOF. So what will happen at that point is that the REPL will inhale those two lines, compile them together. Now you have that done. And then the next line actually uses, I'm making a new instance of C here and invoking the C method. So let's try that. There. So all that happened. It went into paste mode and out of paste mode automatically. Whereas before, I had to type Control D to exit paste mode. With the REPL here document, that's done for you. The special string exits paste mode. So if you're scripting something, now the REPL is a scriptable thing. It wasn't really before. That's new with Scala 2.11.8. Now there's three flavors of REPL here documents. That's one of them. The next one is less than vertical bar. So these vertical bar characters, they're like continuation. So if I type def inhale blah, 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 open squiggly bracket, and then something, the Scala REPL says, I know you're not finished yet because I have yet to find the matching closed squiggly bracket. So I'll just print a vertical bar to tell you that I know that you're not done yet. Okay? And so it says, we're not done yet. There's another vertical bar. Well, if you also have a whole bunch of just a string of vertical bars from something else, and there are places where you would do this, like in build.sbt, there's a thing called initial commands, where every time you start the Scala console, it will execute all of those commands. And there, it's a multi-line string, usually set off with vertical bars. You see where I'm going with this? In other words, you can grab a section of that, not all of it, some of it, and just paste it right in, and it'll execute. You don't have to go and delete all the vertical bars. The REPL will delete them for you. So it's a special use case, but if you're writing scripts, this might be very important. So let's try that. As easy as that. And so it defined the method, it ran the method 3 times. Okay, there's another one, and honestly, I don't quite get the use case on this one. I found what purported to be documentation, and it does work. It's less than dash. Well, is that a tilde? It's a dash. And it just seems to remove leading spaces. I don't know. Tab completion. Okay, this is another improvement in Scala 2.11.8 that is really, I think it's one of the things I like most about that. Those of you who know me realize that I really can't type, but I'm really good at cut and paste. I'm jealous of people who can type. Okay, so this is a random string, and if I hit dot, now I'm about to invoke a method on the string class, right? And if I put the tab character, there we go. Look at all these methods. Now, actually, most of those methods are not in the string class. String class only has a few methods. These are all the methods from predef. Predef adds a whole lot of stuff from implicit classes that show up here. This never happened before. In previous versions of the REPL, if you would do tab completion, you would only see the methods that were defined in that class, which was frustrating because you would go to an IDE and you would see all the methods. Why can't the REPL do it? Well, it can now. So that's nice. What if I type S and I hit tab? Got all the ones starting with S. SP. I've got 3 now. SPL. Split. Now I'm going to hit tab one more time. So this is tab twice in a row. And now it's showing me method signatures that I could use for what I've currently typed. So the first time it said, these are the methods that stem from what you've typed so far. And what you've typed so far, these are the polymorphic methods that you could call. And so, okay, let's do that. I'll split at, if I can type, spaces. Let's try that one more time, shall we? Okay, no spaces yet. I just wanted to show you I have an array of string, all the words. It's split at all the spaces. Okay, so now I'm going to hit tab. Once, twice. So this is code completion for all the methods of array, because split returns array of string. So that's nice, and we could say, oh, let's make a string. I've got my original string back. So that's a really handy thing. You don't have to look up a lot of documentation. It's right there. And it means that IDEs are less important, somewhat. There's a place for IDEs, but sure is nice to have a REPL that does all kinds of nice things for you. Okay, moving on very briefly to the SBT console. Now, the SBT console is just like the REPL, but all of your classes that you've written and all of the dependencies of your project are all placed on the class path before this REPL starts up. So it's in every way similar, except that you've got your project in front of you, and you can goof around with the whole code base. Whereas otherwise, you've just got Scala itself to play with, the runtime, which is exciting and all that, but maybe it's more useful to have the project you're actually working on available to experiment with. So SBT console is usually what you're going to want to run instead of just typing Scala, because SBT console has got your project. And when you want to run the REPL, usually you're trying to figure out what's going on with your project. You want to make something new. Why isn't something working? Show me what is this? If you want colorized output in the Scala console, here's your magic incantation. So you put this into a file of any name that ends in .sbt in this home directory .sbt 0.13, and you'll get colorized output. Okay, so let's talk about tasks. I had said, hey, you can hit Control L with a Scala REPL and clear the screen, which is nice. It's of some use, I suppose. This is more useful. You put this magic incantation in your build.sbt file, and every time you compile your program, first you'll get a clear screen, and then the compiler output. So if you're, instead of having everything mushed together, you can see it fresh each time. So that's very nice. And then something else that's very nice is you have a project that you've been working on. You've written some unit tests, and you want to run the unit test while you fuss with something. There's just this thing you're working on, and it's driving you crazy. So you're writing a unit test, and every time you save, Test Quick looks at the code, it looks at your project, and determines what's been affected by the change you just made, and only runs the tests that's necessary to exercise that functionality. It doesn't run all the tests. That's really cool. I mean, show me another build tool that does that. I don't know of any. So the tilde says, stay in the background, stay running. And every time I save this thing, I want you to run my unit tests while I goof around and finally get it right. So there's plus. It's kind of a modifier for a task. If you're writing a library, who here has written a library? Yeah. So all a library is it doesn't have an entry point. It's a bunch of functionality, which can be linked in with another program that is useful for some problem domain. And it's common for a library to be compiled against many different versions of the Scala compiler. So right now, I've got a bunch, and I'm supporting Scala 10, 11, and 12. Well, that means I need to compile all these things against all the versions to see, that worked on 10. I'm having trouble on 11. It works better on 12, that sort of thing. So how is it that you would actually compile it that way? And so you set up this thing called cross Scala version. is just a list of all the Scala versions, Scala compiler versions you're interested in. And when you say SBT plus compile, it will compile with all those versions for you, and you'll see how it works. And you can plus anything. You can plus publish. So I'm publishing myself to bin tray. My libraries are up there. So if I say SBT plus publish, first what it does for every version of Scala that I've indicated, it does an update, it runs the compile, and then it, assuming that we haven't had any errors yet, and then it pushes the new built version up to bin tray. And so that's amazingly powerful. Now, if you're not writing libraries, this has no value. But if you are writing libraries, that's a thing to know. So it works from the command line, as you can see, or you can type SBT, and when you get the SBT prompt, you can say plus publish, and that'll work fine. So then there's plus plus. This is very cool. I tested this earlier today. You have been running on Scala 2.11.6, let's say, and everything works. And somebody says, hey, 2.11.8 just came out. Will you be supporting 2.11.8 soon? I don't know, I guess. So what happens here is that if you type this incantation in, SBT goes and fetches that version of the Scala compiler, pulls it down, installs it, runs it against your code, and you see what happens. You didn't have to do anything except type plus plus and the version you want. So then some smart person comes along and says, does your code work on Scala 2.7? I don't know. So just type in SBT plus plus 2.7, and it'll go get Scala 2.7 and run it, and probably won't work, but that's okay. So this is good for everybody. You can try stuff out. You don't have to make any changes to build that SBT. You don't have to modify any files. This is all done at the command line. Okay, so looking at dependencies. Who has ever had a problem with dependencies? Sorting out dependencies. And what do you do? Just yell it out. When you have a dependency problem, what do you reach for? Nothing. Crickets. Vodka. Well, it temporarily eases the pain, doesn't solve the problem. But, so what do you do? Say what? Stack Overflow. Okay. Well, I guess that's reasonable. There are different tools that you can use that would try to look at your dependencies and what's called a transitive dependency. So when you write your build.sbt, you say, I need this library and that library and that library. So those are your direct dependencies. And then those libraries might actually bring in other libraries. Those are your transitive dependencies. And what will happen is the libraries that you specified will bring in transitive dependencies of different versions. And that's where the trouble starts. Because the first thing you specified brings in version 1.2. The second thing you specified brings in version 3.4. And there was a lot of change, and chaos ensues. So you have to be able to identify what is it in my dependencies that's bringing in these problematic transitive dependencies. And there's a whole lot of tools for this. SBT 0.13.9, I think it was, introduced this new feature. Every time you run SBT update, it builds a number of XML files in a report directory. The actual directory is target resolution cache reports. And there's a whole lot of them, one for each phase of the compiler. And the Scala compiler has a lot of phases. And it also spews out a bunch of other files. So you'll look in there and say, there's 65 files in there. Which is the one I need? Well, this magic incantation will find the right file for you. And Firefox knows how to read an XML file. Chrome does not. So Google Chrome and Google Chromium, you can't use that this here. I think Safari works okay, and Firefox works okay. And if you just run this from the root of your project, you will see this. a report, which shows all of the dependencies you specified, the versions, the resolver that was used, because that's sometimes you think, where is this coming from, right? How did this get here? Well, the resolver will tell you, well, I found it over here, right? You could even find out what the licenses are. Do we have some mandate, some corporate guidelines as to what licenses we're allowed to have in our project? You can check them out here. How big is it? And as you go through, you'll see cross-references and transitive dependencies. That's a complete, exhaustive list. And now you will know exactly what brought in what, and what version, and why, and where it found it, and how it found it, and everything there is to know. So this is a wonderful thing. Getting to it is a bit of a pain, but if you have the magic incantation, it's not so bad. So just put that in a script, and when you need to see this, run the script, this pops up. Still on the subject of SBT, if you are working on a small project by yourself, it's okay to just have all your code in one project. And you don't need to interact with anybody. So that's okay. But as your project grows, you realize that you're starting to version different parts of it. And you're starting to have different Git branches, or you want to have different Git branches for other parts while you experiment or you do something special over here. And if everything is in one Git project, you can't do that. The only way you can version parts, branch to parts of your program is to have them in different Git repositories. But if an SBT project lives within a Git repository, that means you need to have a way of pulling apart your SBT projects so they can be placed in separate Git repositories. The conventional wisdom, if you go on the echo chamber that is the internet, you will hear everybody saying, use SBT sub project. And I'm here to say that's wrong. What's wrong with it? Well, for one thing, if you have an SBT sub project, by definition, all your code is within one Git repository. So what that means is that all of your subprojects are on the same Git branch. That isn't very good. That's the major problem I have with this approach. And then if you have several people working on it, you're going to have merge conflicts all the time. It's a way of life. And most of those are avoidable. If you had a finer grain of control over the amount of code that you're depositing in each part of your project, you would have less merge conflicts. And another problem is that if you use subprojects, when you grant access to some of it, you must grant access to all of it. And when you do that, it's read-write access up to the whole thing. So imagine you have a subcontractor you want to bring in, and you say, hey, just work on this part, and don't look over here. If you use subprojects, you can't do that. They get the whole thing, and it's read-write. And you have to police the work that they did. You checked in something over there. You're not supposed to work on that, but I had to make it compile. It was a bug. Yeah, but you didn't go through channels. Well, I was on a deadline. You never heard those words, right? So that's what's wrong with SBT subprojects. And that's true for Play as well as Scala. So external SBT projects is where you actually have multiple Git repositories, each with its own SBT project. And you stitch them together with Git subtree. I'm not going to go into how subtree works. And there are other options besides subtree. But I think subtree is the one you might like the best. And that solves all of these problems. Now, you can have different parts of your project with different branches. So George can go over here, and Fred can go over there, and they can do what they need to do. And merge conflict problems are greatly eliminated. So it sounds good. How hard is it? Well, it's not. It's actually really easy. So I have for you prepared a little demo thing. There are 4 projects. I have in the top here, underbar model. That's a value object, has no business logic. It's just got fields. Case classes with fields, essentially. There's no methods, nothing. Just your value objects. And then in the model directory, I've got business logic associated with some of those fields. And you can see that I've defined in the value object thing, the top one, I'm saying the project is .in file current directory. So in other words, this underbar model is saying, whatever you find in this directory is everything I want you to look at for this SBT project. And the other one says, this project depends on that project, and you will find it over there, up and over, one directory, and we're going to call it base model. So now they're linked. And the Scala compiler, well, actually SBT knows that when you change something in the top project, that this thing needs to be maybe relinked to at least and possibly recompiled, depending on what happened. So it keeps track of all of that for you. All right, so let's, we've got a third project now, and this is a console application, and it depends on the other two projects. Now, I've written this in such a way that IDEA will understand it. In actual fact, I could have just said the bottom project reference, it depends on model, because model depends on underbar model, it would have brought it in. But IDEA doesn't quite get that part. So I specified the transitive dependency of underbar model so that IDEA would work, and I'm going to show you what that looks like. So this is like an actual application which brings in these dependencies. They're in different Git projects, handled by different people with different access privilege. So maybe I let my front-end guys see the back-end code, but they can't touch it. I mean, they can't modify it. They can only, when the access I've given them for that Git repository is read-only. So they can't do any damage. So here's a web app, and this time I've said enable plugins play Scala, so that's what makes this a play web app. Somewhere else I've defined that there is an SBT plugin that is play Scala. I'm just enabling that, and it depends on the same things as before. So you can see that you can create a play web app in just the same way as a console app in a modular fashion. It's pretty simple. There isn't anything else to know, really. Yes, you can look at the docs and get more complicated, but this really handles the case. It's not a lot of code, not hard to figure out, but it gives you a lot. And I wanted to demo that. Here's the play app. I can only zoom this pane. I can't zoom this pane, and that's the pane I want to show you. So this is model here. This is the play web app. I'll just close that up. And here's underbar model. So look at that, 3 top-level projects. And I've got all their code. And I can go in, I can change any of that code if I have write access. And all the dependencies will be worked out. So maybe you've been doing publish local if you're a library developer and doing the dance that way. You don't have to. This is a better way. So much easier. And so simple. There are some other mechanisms too that people talk about, and I don't know why they exist, because this does the job so well, and it's so easy to work with. So let's look at these files. Here it is. Let's start at the top. Build SBT. This is that line I showed you before. That says this project is called base underbar model, and it just consists of the files that you see in this directory. And then model, and here it is up here, it's the model name here, for some unknown reason, has to match with the model name here. Another project called model, which is depending on underbar model, and it makes itself known by the name model, because that's the name of this variable. The name of the variable is actually significant. That's not what you would normally find in a program. You could call, a rose by any other name, it would smell as sweet, right? If you call it Fred or Rose, it's still going to have the same information in it. That's not true in this case in SBT. The name that you choose here for your project matters, because that's the name that's its ID. Here's where I pull it together, and I can make this bigger. There. So what I've done is I put 2 project refs. Although SBT doesn't need me to spell out all the transitive dependencies, IDEA does. If I didn't, I wouldn't see underbar model at the top here. It wouldn't show up. But because I put it here, IDEA works. And so this says, basically, my Play web app, you can look at it. I mean, I can attack this thing at many levels. And I split it all out. These are all different Git repositories. And so I can control access, and I can branch on each of those Git repositories independently. I'm not going to demo this. I just wanted to say that this is a whole interesting thing. If you're a Mac user, and probably most of you are, Tmux works really well. If you are a Linux user, as I am, frustrating at times. So if you are working on a server, you have command line access. You do not have a GUI, and you want to edit in a pane and have a compile in a pane or something like that, Tmux is a great thing to do. I wish there was a standard tmux.conf. This is a plea for help. I have put a lot of time into getting a really nice tmux.conf, and it's always lacking somehow. I've seen some people with really sexy looking things. Please publish them. We need more support out in the Scala community for Tmux. Okay, so I have a whole lot of stuff on IDEA now. So I have some plugins, Terminal, Markdown, regex. Who's using IDEA here? Okay, so let's see if any of this is news to you. I know you can't see it, but in here I've installed the optional regex plugin. Now there's two plugins that you can get. Settings. Plugins. There's 2 places you can get plugins. You can get the official JetBrains plugins, and then you can go to the community. So the regex, I've gone to the community. And there's several different ones. They're already installed. So you've got your regular expression up here. These are Java regular expressions. And then you've got your data down here. And you can say, .all or whatever modes, switches you want. And whether you want to do a find, a match, a split, or a replace. And it kind of gives you a preview of what will happen. So this really makes your life better. I'm a big believer in regexes. I love them to death. But without a tool like this, it would be a lot harder to work on regexes. And so there's a couple of really good regex testers available in IDEA. Other plugin I like, this is, again, I don't think this is an official IDEA plugin. Terminal. If you're a Windows user, sorry, it'll come up, but it'll show you the CMD command processor, which I have no use for. But if you're on a Mac or a Linux box, then you're going to be brought up. The current directory is the top level directory of your project. So immediately in the right place. So I have right now, you can't see, but I've got about 6 instances of IDEA running. And if I brought up the terminal in each instance, they would all be in a different directory, the right directory for the project that I'm in, which is nice. Now I'm used to command line Git because that's just how I learned it, and that's how I think. And there is a great Git client built into IDEA, and you may like it. I'm not saying you shouldn't, but I do my Git down here. I do my branches and my commits and all that. I type it all right in here. You can type other things, any command you want. It's all there. And then you can put it away when you're done. So it's not uncommon for me to say, oh, that's good. I'm going to do a release right here, and I'll push up, So you don't have to be flipping to something else and opening a shell, and, you're right there. What I do want to show you that you have to see it to appreciate it is the split editor support. And if I could find my mouse, there it is. So split vertically, split horizontally. I can close my project tab. Alt-1 does this if you have Eclipse bindings. And I can open up another directory. So actually, I'm in, see that? There's breadcrumbs available. And I don't need my project pane in order to open a file. So I'll just open some other file. And that's over here. And say, oh, you know, I'd like to split that. I can't see. Let's do that over here, because I can't see over there. It's the overhead lights. There. And I can resize it. And I can drag from here to there. That kind of thing. And I can say move to the right, so it's split to the right. So you can do this sort of thing and go crazy. That's a very nice thing to have. So another way to get the breadcrumbs, I mean, you want to use the keyboard as much as possible and the mouse as little as possible. Alt up on Mac, Alt home on Linux and PC takes you to the breadcrumbs, where you can then arrow around and look at stuff. So that's nice. And then I can hit enter, and it opens the file. I can bring my pane back, project pane back, or I can hide it again. There's also a structure pane available. Takes a second to come up, and it shows you the classes and methods and so on. And you can control the visibility of things. And I'll say, well, please sort it alphabetically for me, or not. Just show it in the order of appearance. I want to see Scala tests. I want to see what inherited methods or not. There's our inherited methods. So you can, then you can go somewhere. So mulstring, there we are. We moved over. Or you could say, you know what, I don't really need the project pane. All I care about is this. Or you could say, no, that's not true. Or you don't need any of it. Anyway, you've got control over that kind of thing. That's a nice thing to have. Let's say I have a file, some random file, and I want to know where is that in my project? What directory is it in? What do? You go searching for it? Push this button here. It's a little X in a round thing. And it opens up the project pane and takes you to that file. What a wonderful thing. So it'll take you to wherever you need to be. Here's something really handy. I'll go to scroll to the source. Here we are. If I right click on that, I can say, where is it? Local history, show history. I don't have much in the way of history, but it shows me these aren't checked in changes. This just saved the work I've been doing periodically, and I can see how things have changed. Well, that's nice. But what I find really helpful, where did that go? Here it is. Git compare with branch. This is so cool. Now, this doesn't, to me, I didn't notice this the first couple times I used it, and I didn't see this little box because it's not bright enough, and I thought it was broken. But I'm just telling you that it comes up, this little nondescript, modest box, and I can go and compare the file I'm looking at to any branched version of that file. And so let's do that. And you can actually do a merge right here, because this is also their merge tool. It's not just a view. And as a merge tool, it's great. I really like their merge tool. So I spent the last 3 weeks doing a monster merge from a branch that had months of work that's kind of went sideways. And I cherry-picked out all the good stuff, and I brought it into master. And I lived here in this for a while, and I put some hotkeys so you could just like, show me the Git history. Fantastic. Oh, external files. Okay. So as you know, your SBT files have got dependencies, and some of them have transitive dependencies. External libraries are down here at the bottom. And if I open that up, these are all the dependencies of my project. And they live in your home directory under the .iv2 directory. And what IDEA has done is figured out all the dependencies and presenting them to you as if it's part of the project, because it is. But they're actually in a whole different part of your hard drive. And I can open up any one of these. And even if I don't have source code available, it'll decompile it for me. And I can look at it. If I do have source code, it will show me the source code. So this is a nice thing. You can place breakpoints in here. You can debug. You can figure out what the problem is. So also you'll see what the versions are. You say, hey, you know, that isn't right. Why isn't that right? And it's quite often I'll say, I have a dependency issue. Well, another thing I wanted to show you was, if you wanted to know what are the dependencies of the meta project that SBT uses, here they are. So that's under SBT and plugins. So SBT can have meta build projects. The project that builds a project that builds a project that builds your project. And so you could have many different levels of this. So this is what SBT has hauled in, and you can take a look at that. Generally, unless you're writing an SBT plugin, you might not care. But sometimes this does matter. Okay, so this is kind of thing. I said there was one hard slide. Are you ready? Here it is. What is a type? You guys will know this probably. A type is a classification that the compiler can verify. But a class is a definition that can be instantiated. Am I speaking too fast? So a class is something that you can make. And a type is kind of like a definition of something. They're not the same. So in Java, for example, a list is a raw type. In Scala, a list is a class, but it's not a type. It's a higher kind of type. A list of a string is a type, but it's not a class. Int is a type, but it doesn't have an implementing class because it's provided by the Java runtime. Null and any are types that don't have instances. The nothing type doesn't have values or an implementation class. So, given all of the foregoing, what type does X have? Might be any val. By not writing the type explicitly, you leave yourself open to the kind of stupid error where X doesn't have the type double as you think it should have, and all kinds of weird stuff happens. And so the moral of this is, write your type. Explicitly write your type. I know it seems redundant, but you avoid the stupid errors. I'm going to skip over a lot of this, but I'll just try to hit a few things. This is something I'm going to talk about. Call by name. There's something people don't realize about call by name. So you have functions, and you have methods. And you know that when you call a function or a method, the compiler goes and executes some code. And each time you call it, you will do pretty much the same set of mechanics. And then there's a thing called a val, which you execute some code, you get a value, and that's the value. Next time you ask for what is the value of this val, you get that value back. It doesn't execute the code again. It already knows the answer. And you have a lazy val, which kind of delays the computation until the time you ask for it. And most of the time, it comes back with the answer that you need. Call by name parameters. It's kind of something that I wish was a little different about Scala. C++ has the ability for call by name. You know that when you call a call by name parameter, that there's a little ampersand there. You know that this is going to be like a call by reference. You know that it's a little different. There's no indication in Scala that you're doing that. It all looks the same. You'd have to actually examine the definition. This definition here, this is saying, don't compute this value. Kind of make a little block of code, hold that aside, and whenever we encounter a usage of it, then I want you to go ahead and compute this thing. And if we don't end up having to compute it, we'll never compute it. That's okay. when you invoke this method, you have no idea that this particular parameter has that characteristic. It's only if you examine the source code that you're calling that you would know that. And I wish it wasn't that way. But anyway, the thing that I wanted to really say was, notice that the block is sent to something called result. If I had referenced block twice here, it would have been computed twice. And so the habit you need to be in when you're using call by name is that when you decide that you need to perform the computation, you save the computation in some other variable and you only reference that. Otherwise, you'll recompute the same thing over and over again to no end. If it has side effects, horror of horrors, it will be even worse. So IDEs are able to do a code analysis, and they're able to show you, hey, this parameter is a call by name parameter. It can show in a different color, it can be highlighted or dimmed or italicized, but however you want to decorate it, then you would know, it's one of those. So it's just something to be aware of. You can get some interesting behavior if you don't know about this. Okay, what does this program do? Please? Going once? Going twice? Shall I walk you through it? Okay, I'll walk you through it. The weird thing about this program is this thing. What's this? I say object backtick quote. So in Scala, you can backtick, close something in backticks, and the compiler will allow you to write anything you want in there that would, without complaining. You can't normally call an object package because package is a reserved keyword, but it's in backticks. And so what this actually does is it makes a package object. And I didn't have to put it in a special file or a special package because of the scoping. Package yeller, this is the package object for package yeller. It's kind of an idiom. So you've probably never seen it before. The first time I looked at it, I said, do I like this? Yeah, actually, I do like this. Once you realize it's a thing, it's very succinct. It's bizarre. Maybe someone's going to tell me I'm stupid for saying this, but yeah, I think it's kind of cute because now I can have this implicit here and it's associated with that, and you can see they're right beside each other by proximity. You know that these are related, and I like that too. So it's got some nice, this makes it very readable. So what happens here is that case class yeller is just a wrapper around a string. It just holds the string. And it provides a method called yell, which converts the string to uppercase, puts exclamation marks behind it. And here's an example of using it. Lookout.yell, and it prints lookout in uppercase. Does this remind you of anything? This is kind of similar to something else. Is that hint helpful? Does it remind you of an implicit class, perhaps? So how would you write this so that it was more efficient by using value classes? And why would it be more efficient if you used value classes? Yes? What cost? The boxing and the unboxing. Yes, and how would you do that? How would you avoid that cost? Oh, yes, extend any val. Exactly. Right. So just by adding case class yeller and at the end extends any val, then providing that we follow all the rules for implicit classes, and there's a bunch of them, then when you write this kind of code, the compiler says, okay, I'm going to pretend that I've wrapped it in a class, and I'm going to pretend all these methods are available, but it doesn't actually generate all that code. It just makes this work. And so at runtime, it's very efficient. It has a little more work to do at compile time, but who cares? So that's kind of cool. So value classes are a good thing. I'm going to skip this. Here's something that is probably worthwhile. I'm skipping it because I'm pretty much out of time. Scala 2.12 has an implicit ambiguous statement, and here we have, I'm going to give you a simple example. The reason I do this is that the documentation is, the example is bizarre. So this is somewhat contrived, but at least more understandable. I've got a case class called X. It's parametric in types C and D, and it accepts values of C of type uppercase C and D of type uppercase D. And I can define an implicit called ambig1, which is parametric in type J, and accepts an instance of J, and it returns an instance of a X. So it turns J's, whatever those are, into X's. Now the thing is that we don't know what J's are. And by writing it this way, pretty much anything could be a J, which is interesting and problematic. So I'm not recommending that you write your code this way unless you really understand that this makes sense. Because most of the time you write this kind of stuff, it's wrong. Because this is happily take anything, say, that's a J, and try to do a conversion. So anyway, the point I'm trying to make is I have prefaced this, decorated this implicit def with implicit ambiguous and a little error message. So along comes a second definition. It looks very much like the first one. The only difference is it's called ambig2. It's just the same. Now they're both in scope. They both match the same criteria. So when I write this, J is of type int, and lowercase j has value 1. And so we're going to take 1, we're going to try to turn it into an X. Which implicit should it call? Well, the compiler says, oh, I don't know. Idiot, look, you put two of these in scope. And it gives you the error message that you asked for. So that's what release 12 is giving you, is the ability to have the error message that makes maybe more sense for you. And please don't write your code this way. You'll probably get hammered in a code review. Oh, okay. I'm often asked by puzzled students, what is the minimum play? What makes a project a play project? What is it about this pile of code that differentiates it from another pile of code that isn't a play project? And there's 2 lines, and here they are. In your build.sbt, you have to write this magic incantation pretty much the way you see it most of the time. It says, for everything in the current directory and everything below, that's my project. And I want to turn on the play Scala plugin, which is an SBT plugin, and in this file, sorry, it should be a lowercase p, project whatever.sbt, because it doesn't matter what you call it, you specify the plugin. With that, you have a play project. That's all. It's the only thing that differentiates a play project from any other project. It's just an SBT plugin. It tells SBT how to behave, which directories are source directories, and some other things that it has to do that are different from how Scala normally behaves. And it also makes some dependencies available. That's it. I have an issue with twirl, the play templates. It's good for simple things, but it makes medium things difficult and complicated things nearly impossible. And so here's the rule, here's the criteria I use to determine should I write a view in twirl or in pure Scala. If I need to cache some of the response, like my Cadenza web app caches all kinds of stuff because I compute it once and I save it, and then next time it's needed, it's there. Well, that's very difficult to do in a twirl view. So if you want to get performance, you're going to start moving away from twirl for those views. If you have a lot of conditional tests, it's awkward in twirl. You end up writing this code that's just a mixture of HTML and Scala and other stuff, and it's very hard to read. And IntelliJ doesn't parse it very well, and Eclipse doesn't parse it at all. So that's pretty sad. If you need to do nested looping to more than one level, it gets messy fast in Twirl. If you have blocks of code that don't fit on the screen, I mean, in general, if I can't see my logic on the screen, then I want to refactor, because I'm just dumb that way, but I think you shouldn't be dumb. I think that's a good thing. Don't make me think too hard, because I have to work all day, and brain isn't always working as effectively as it might, so make it easy for me. Show me everything I need on the screen. So Twirl doesn't follow that precept at all. Here's your code. My goodness, that loop starts up here, and 3 feet down there it ends. That's ridiculous. But that's Twirl. So when you have that happening, you know you want to rewrite it. Because in any editor, even regular text editors, you can collapse things like strings, many lines into one. And there's a string, you can see the first part of it. The rest you don't care about. But when there's embedded logic, you might need to see it. And so in that case, Twirl loses, plain old Scala wins. If you need to compute multiple variables for a block of code, you know, if it's a dimension, X and Y and Z and I don't know what else, things get awkward. And if you have several templates that share common code and you'd just like to put them all in the same file, you can't do that with Twirl. Every template's in a separate file, so you end up with files all over the place, which they could be really short. I mean, 2 lines calling something, you know, common. It's just no. Now the downside is I have logged improvement request with JetBrains on this. IDEA doesn't understand how the packages work. In Twirl, you have a view. So it's in the view directory. Let's call it Fred. So the file type is view.fred.scala. View Fred HTML.scala. And that compiles to view HTML. So the full package of the compiled thing is view.html. And so it shifts, and the reason it is code generation that happens. Play will take your Twirl template and emit some actual Scala code, which is not in the same directory as the original code was. So that means that if you want to have your Scala views in the same directory as your Twirl views, which I do, because logically they go there, they're going to be in different packages. And IDEA will say, hey, you might have made a mistake. It'll be underlined. Your package could be wrong. And it's not wrong. So it's an annoyance, but it doesn't stop me from writing. Here's an example. I'm calling something called includer. This is an actual piece of code that will include a file from somewhere on your hard drive and put it on a web page. And here it is. It's all pure Scala. All it is an object with some name, and notice it's a lowercase because that's just the convention for play templates. I've got an apply method. It doesn't have to be called apply, but it could be. And I have some code. And it outputs HTML. The HTML is a type defined in play. So that's all. It's just an object with methods that return HTML. That's all you have to know in order to do a pure Scala template. Easy, right? So I write as much as I can this way, because I can maintain it, I can refactor it, I can debug it. Try debugging a Twirl template and see how you feel. You'll end up rewriting it. I'll just give you the punchline, because we're out of time. So the echo chamber that is the internet says that if you're deploying a play application, SBT stage or SBT dist is all you need, and they work great. And what's also true is that if you do that, you end up writing a lot of glue code to actually move your code into this place and set the permissions and start it up at the right time and make a daemon and blah, 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 blah. So that's not a good way of making your code, but the echo chamber that is the internet repeats what used to be true. Once upon a time, those were your only options. But there is this thing called SBT Native Packager, and it has improved a lot in the last year. But the documentation still needs a little work. How much work, you ask? I spent 130 hours preparing a half-hour video. That's how much work. Now, I've done it, and this one lecture is worth the price of admission for the whole play course. Because imagine, you're working on a project, there's a bunch of you, you've spent weeks or months on this project, it comes time to deploy, and you do some hokey little thing that breaks. When there's a better way, it just, understanding how it works is not so easy. Once you see it, you say, oh, it's easy, I can work with that. But you, the journey from, I'd like to use SBT Native Packager to actually having it work in a play application in a way that's maintainable is fraught with time sinks. So I did a lot of work here. I think I'm very proud of it. I think that you all should, if you're using Play, should watch this video. I don't have time for this. We have a course on Wildcard SL certificates, and if you want to get this grade on your Play app, that $99 course will show you how you can do it in one day. You can run through the whole course and have your web app getting this grade in one day. It's really been shrink wrapped. Okay, bonus and I'm done. Yay, bonus and we're done. So the bonus is this. More, better, faster. So Richard Wallace reported a few days ago, I think it was Friday or Thursday of last week, he turned on the new optional Java 8 backend in Scala. He found bytecode size dropped 50%. Compile times decreased 75%. And you have to be using Scala 2.11.8 and Java 8, and you can get some pretty amazing things. I wouldn't use this in production. I would use it in development. But then that's when you want this kind of behavior, because it's too new. I mean, I don't trust this for production. But it's fine. In development, you can save a ton of time waiting for compiles. So here's the magic that you need to know in order to do that. Put this in your build SBT in the Scala compiler options, and add that dependency. That's it. And you'll have faster compiles and smaller object code. But don't do it in production yet. Next year, you can do this in production. Thank you.